All right, in section 5.5, we're going to go ahead and use some of those concepts of a logarithm that we talked about last time to solve for an exponential equation. So just like in general, when you're trying to solve for an exponential equation, you're trying to figure out what the value of the variable is. So the idea is you want to isolate the variable that is in the exponent. So in general, there'll be a variable in the exponent. That's kind of the distinguishing feature of an exponential equation. So we want to isolate that. Now, the way we'll do it, if we have a variable in the exponent, generally, pretty difficult to get that by itself by traditional methods. So if I have, for example, 3x equals 5, I can't divide by 3, so that doesn't help me. I have that x up there. Really, the best way to do this is to change this to a log. So if we recall, we said if we have b to the x equal y, the rearrangement of that is x equals log, because remember, log is an exponent. So this exponent goes by itself, log base b of y. So being able to change these exponential equations into a log is the best way to do this. So this one we could simply just say is x equals log base 3 of 5. Now, log base 3 of 5 is a number. Now, if you have Desmos or a fancy graphing calculator, you could just type this expression in. If you have just a generic calculator, that's okay. The way we type logs with different bases, there's always a log button, but if I type it, a lot of times it won't let me put a base in. So the way we'll type it is log 5 divided by log 3. That's the way we'll get our approximate value. So log 5 is a number divided by log 3, which is a number, is going to be approximately 1.46 if I go to 2 decimals. And in general, these will always be irrational, weird decimally numbers. Now, just one note about this. To do these problems, you do have to have it in exponential formula. You have to have a base to some power equals y. You can't have like a number multiplied out front here. You got to get rid of that if you do. You have to have it look just like an exponential equation. If it does, no problem. So let's go ahead and look at some examples of how we will isolate this variable. So this first one says 2 to the x equals 5. So this is our exponential equation we're trying to solve. So the first thing, is it in a normal exponential? Is it a base to a power equals a number? Absolutely. So I can pretty much directly switch this to log. So this would be x equals log base 2 of 5 when I rewrite it. So remember, if you don't have the fancy calculator, we'll just say this is log 5 divided by log 2. So log 5 divided by log 2. When I put that in the calculator, I'm getting about 2.32. So what that value means is it means if I take 2 to the 2.32, it will give me approximately 5. Remember, we are rounding these things. So in rounding, we're going to obviously have a little bit of error. But if you put 2 to the 2.32 in your calculator, you'll get something super, super, super close to 5. A little under 5, but really, really close to 5. Let's go ahead and look at this one. So we have 3 times 4 to the x minus 1 equals 6. Now here's an issue because it's not really a number to a power equals something because we have this 3. So I got to get rid of this 3. So I can certainly divide both sides by 3. Get me 4 to the x minus 1 equals 2. Now you might be concerned because there's an x minus 1 up here versus an x, but that's okay. It's something up in the exponent. So when I rearrange it to log form, it's going to be that exponent, the whole exponent, no matter what's up there, equals log base 4 of 2. Now, log base 4 of 2 I can certainly figure out, but really in general, I'm going to figure this number out, and then I'll just add 1 to it to get the x by itself, because the exponent wasn't just x. So in the calculator, we'll do log 2 divided by log 4 plus 1. So that is going to be my final answer. So I'll put in the calculator log 2 divided by log 4. And I certainly encourage you to type this in your calculator as well. I get 1.5. So this one's a nice one. 1.5 exactly is the solution to this value. Now this one's got a lot going on. We've got the 210, we got the 10, we got the 42. We kind of got a mess here. So the goal is, so you see our exponential is here. So everything else I got to kind of get rid of. Now I don't care if there's extra stuff in the exponent, but I can't have the extra stuff in the equation. So I got to get rid of the 10 and the 210. So just like normal algebra, I'll go ahead and subtract that 10 out. So I'll get 210, 42 to the x equals 70. And then similar to the last problem, I'll divide by 210. So 42 to the x. Now you can keep it 70 over 210. This also reduces to 1/3, but if you kept it as 70 over 110, that's certainly okay. So now it's ready to switch to log form because it's a base to a power equals a number. So x is going to equal log base 42 of 1/3. So if you're putting that in the calculator, it's log of 1/3 over log of 42. Always the base number on the bottom. So I'm just going to type that in, log of 1/3 divided by log of 42. And I'm going to get negative 0.29. Now this one is a little different. We got e to the x over 4 as our exponential base. We got a 14 and a 168. No problem. Same old idea. First thing I would do is I would divide both sides by that 14. Get rid of it. So we get e to the x over 4 equals 168 over 14 is just 12. You can check that if you like. Now this one's a little different because we have this magic base e. So if you recall from the last section, we said if you have base e has a special log. It is the natural log. So natural log is a base of e. So the way that we would formally write this is we'd write our exponent equal to log base e. Well, when I write log base e, I can just write ln. I don't have to write the e is assumed. Now, if you put the little e, if you put under here, could you put log base e of 12? It's not wrong, it'll work. But in general, when you have a base e log, it's more formal to write it as the natural log. So now to get x by itself, I'm going to multiply both sides by 4. So x is going to be 4 ln 12. There is a natural log button on your calculator, so this is kind of nice. You don't have to do 2 logs because there is that natural log button. So this gives me about 9.94 if I round to the nearest hundredth. Now any other log, you kind of have to do the 2 logs and split them, except for e, and I guess base 10, because a log without a base is also considered base 10. All right, let's look at another one. So this one we have 9 times 2x equals 64. So same idea. I will first get rid of that 9. So I'm going to divide both sides by 9. So I'll get 2 to the 2x equals 64 over 9. 64 over 9 doesn't reduce. It doesn't really matter if it does or not, because I don't really need to worry about it. So I will turn this to log. So the exponent, the 2x, equals log base 2, 64 over 9. So now to get this, we're going to, of course, have to divide by 2 to finish it up. So x is log base 2 of 64 over 9 over 2. So if I was going to write this in my calculator, I'd do log 64 over 9 divided by log of 2. So I'd probably just put that whole thing in parentheses, and then I'd divide it by 2. And that'll give us our value. So I'm just going to type in the calculator log of 64 over 9 divided by log of 2. I have that in parentheses, and then I'm going to divide that by 2. You could also get the answer to this and then divide it by 2 in the next step. All those would be fine. get about 1.42. 1.415037,499. So let's look at one more. This one has some decimal elements to it. When we start doing compound interest in some of these applications that we're going to do, we'll certainly have some of these kind of decimal things. So obviously 3.2 equal 1.12, 0.44x plus 1. I'm going to go ahead and want to get rid of this 1 first. So we'll get 2.2 equal 1.12, 0.44x. So it is an exponential form. It's a base to some power equal a number. So I'll switch it to log. So the exponent equals the logs. Logs are exponents, but it's log base 1.12, 2.2. There's nothing to say bases can't be negative, or can't be decimals. They can't be negative, but they could be decimals, they could be small, whatever. So then I divide out, so log of 1.12 over 2.2 divided by 0.44. So again, I'll put that top in as log of 2.2 divided of log by 1.12 divided by 0.44. Just getting it by itself. So if I put this in the calculator, log of 2.2 divided by log of 1.12, all in parentheses, divided by 0.44, I get 15.81 approximately. So those are just a couple exponential equations for you. Obviously, we'll practice some of these, and if you have questions, obviously, please let me know.